Hi, my name is Hana Matatov. Today I'm presenting our work about the role visual content played during the 2020 United States election misinformation campaign. This work focuses on two aspects. First, the Stop the Steal misinformation campaign surrounding the 2020 United States election. Why this misinformation campaign is meaningful? During this campaign, misleading claims of voter fraud were spread, including allegations that the election was stolen and calls to overturn the results. The claims shared on social media platforms such as Facebook and Twitter, and on January 6, 2021, a mob of Trump supporters attacked the Capitol building in Washington, D.C. Moreover, the campaign influenced democracy and public opinion to such an extent that, as of December 2020, approximately a third of the United States population didn't trust the election results, a number that remains similar nearly a year after the election. Second, our focus in this work is the visual content that's shared during this campaign. Why visual content? Images are spatial. They can attract attention. See, for example, the difference between these two posts with similar content. Images are more persuasive and provide an evidence that something happened, and they can trigger stronger emotional reactions. Images also can speed up the propagation of content because of their ease of share. Those images are frequently used in political campaigns and play a significant role in online misinformation. Therefore, in this work, we aim to expand our understanding of the nature and dynamics of popular images shared in such campaigns, using the Stop the Steal Misinformation campaign on Twitter as a case study. We take a mixed method approach to analyze the popular images. Particularly, we set out to characterize three aspects. We start with categorization of the types and roles of the top images that were shared in this campaign. Then we explore the temporal patterns of the spread of the popular images and the role of different users with different network prominence in sharing the images. To this end, we use the Voter Fraud 2020 dataset, a multimodal Twitter dataset with tweets and retweets that include key phrases related to voter fraud claims surrounding the 2020 election. This dataset includes almost 8 million tweets and 26 million retweets from 2.6 million unique users, and also 168,000 media items that were shared with the tweets and their metadata information. We use perceptual hash values of the images for finding appearances of the same image across different tweets in the dataset. And we extracted the most shared images by promoters of voter fraud claims. We ended up with examining a set of the 40 most popular images. Each was shared at least 1,000 times within the dataset. Now I'll talk about our analysis and outcomes. We wanted to understand the types of images that reach popularity and their role in this campaign. To this end, we used a qualitative process based on an exploration of the images and the context of how they were shared in tweets, looking at tweets' text and associate URLs, if any. This way, we created a codebook with 4 image categories and their associated labels, including the categories type, origin, content, and role. For example, here you can see 2 images from our dataset and their labels. We found that only half of the most popular images we examined were photographs, and 40% of the images were actually text rendered as images. None of the images was a manipulated photograph, and only 1 was a meme. Only 5 images labeled as evidence, presenting a photographic attempt to provide evidence of the alleged voter fraud, but these images were some of the most commonly shared. We analyzed also the temporal patterns of the spread. We found that the images spread very quickly. Almost 50% of the images reached the half of their spread within only 3 hours from when they were first found in our data. We calculated the half-life of the spread for each image, the time until the image reached half of its total shares in our dataset, and you can see here the results in the figure. 19 images reached their half-life within 3 hours, and after 7 hours at most, 75% of the images already reached half of their total shares. We explored the distribution of shares of the examined images based on the popularity of the users who shared them, and we revealed a mixed participation pattern where accounts of varying popularity participated during all stages of the image's propagation. But the images labeled as evidence were shared less by larger accounts, meaning accounts with more than 1,000 followers, compared to other types of images. For example, while the average percentage of shares of the evidence images by users with 100 to 500 followers is higher than other types of images, for users with 1,000 to 5,000 followers, the opposite happened. It's possible that these images simply received more attention from spammy or bot accounts, but another possible explanation is that these popular users were careful about spreading more explicit misinformation. To conclude, our results expose and provide implications for the challenging landscape for moderation of misinformation. Moderation can apply to content and to accounts, and may include content removal, attaching warning labels, account suspension, and more. First, many of the popular images used in this campaign may not by themselves have violated content policies, only the additional context made them problematic. Second, the images get most of their spread quickly, requiring moderation to make an extremely quick decision to be effective. Finally, the user's mixed participation pattern make it hard to control the spread by suspending selected users. However, in the paper, we show that repeat and early offenders exist within the popular accounts group, which may offer guidelines for selective enforcement. Thank you very much.